Hi. So now we're going to be looking at an intermediate value theorem problem from a previous AP exam as well. This time we're told that f is a continuous function such that f of 2 equals 5, so I have one ordered pair, the ordered pair 2, 5, and f of 5 equals 2, so I have another ordered pair, the ordered pair 5, 2. We're told that we're going to let h of x be the function f of x minus x. And we're asked to explain why there has to be a value r such that r is between 2 and 5 and h of r has to be equal to 0. Since we have a continuous function for f and we know that, now I can go through and I can show that first of all h is going to be continuous, and then I can show that based on the intermediate value theorem that means that I'm going to have to cross the x-axis when I graph h of r. So the first thing that I'm going to do is I'm going to say, okay, since f of x is continuous, subtracting another value, subtracting x is going to be continuous. Since x is continuous as well, I've got the difference of two continuous functions. That means that that function is going to be continuous as well. So since f is continuous, that guarantees me that h of x is continuous as well. That's an important piece of this puzzle because I can't use the intermediate value theorem unless I know that I have a continuous function. So now I've resolved the issue of whether or not I have a continuous function. So the first thing that I'm going to do is I'm going to evaluate h of 2. h of 2 is going to be equal to f of 2 minus 2. Plugging in x for 2 here, plugging in x for 2, plugging in 2 for x here, 2 for x here, and 2 for x here. We're told that f of 2 was equal to 5 minus 2. So that means that h of 2 must be equal to 3. Now let's evaluate h of 5. h of 5, plugging in 5 for x there, 5 for x there, and 5 for x there, gets me to see f of 5 was 2, minus 5 gets me negative 3. So now I have a continuous function. At h of 2 I was equal to 3, at h of 5 I was equal to negative 3. Since I'm a continuous function, when I cross from 2 to 5, I have to hit every value between 3 and negative 3 because of the intermediate value theorem. So now I can say that by the intermediate value theorem, and we can just abbreviate that IVT, by the intermediate value theorem, there must be a value r between x equals 2 and x equals 5 such that h of r is equal to 0. That really is all I have to show. I have the meat of the problem here. I've said that I have a continuous function for h. I've evaluated h of 2 and found that it was positive. I've evaluated h of 5 and found that it was negative. The intermediate value theorem applies, so I know that now I can just make that statement that since I'm going from 3 to negative 3, I have to have crossed 0 at some point. This would get you full marks on the AP exam for this part of the problem.